Hello, what's up everyone? New week, new live stream, and this time we're going to explore and discover not something new that has been announced at WWDC, but actually a package that has been around, as you can see, something like 3 years now. It's a package called Swift Algorithms. So it's an official package made by the Swift team, and it contains, well, as the name suggests, algorithms. But basically, you can see it as like a helper function and methods that could have been in the Swift standard library. For some reason, they decided that they were not maybe generic or of a broad enough usage to put them into the library that every app will include. But still, they wanted to make them available, and so they created this package. And the reason why I want to cover this package today is because I had a discussion with someone on Twitter about it something like 2 weeks ago, and it made me realize that even though I am aware that this package does exist, I think I have never actually used it in any of the apps that I have worked on. For comparison, I have used async algorithms, which is a package with a similar approach, but for asynchronous operations. Actually, I had done a full live stream exploring async algorithms something like 2 years ago. It might even be exactly 2 years ago because it was July 2022. So it might even be 2 years ago, almost on the exact same day. But besides this coincidence, what did I wanted to say? I lost my train of thought. Yes, so I was like, okay, Swift algorithms, maybe I should actually pay attention to it because maybe there are some useful functions in this framework. And what I saw is that not only do you have the source code available on GitHub, but you also have, let me show you, you have all of these nice little guys that go over every single function inside the package. So as you can see, there are not that many functions. If we count them, so we have 3, here 2 others, so 5, 9, something like 9, 13, 16, 18. Okay, here is the same thing. We'll see 20, and here maybe 10. So there are 30 functions, give or take. And so I was like, why not go over each of these functions, try to see what's their purpose, try to see whether there are some use cases that naturally come to mind where they could be useful, and why not try to make a top 3 or a top 5 list of functions in the Swift algorithm package that are worth knowing as an iOS developer. So by that, I mean functions that if you know that they exist, there is a chance that in the coming year or the coming 2 years, you will have a genuine need to use them. I'm not talking about trying to shoehorn something into an app just to say, oh, look, I know this framework and because I know about it, I want to use it. I'm talking about a genuine use case where it actually makes sense to use the framework, or rather I say framework, I should say the package, because it's a Swift package. Even though in Xcode sometimes framework and package are used to mean the same thing, but it's a Swift package. So as with most Swift package, it's available on GitHub. You have access to the source code, and I just want to show you this in the intro because it shows a good example, I think, of what's inside Swift algorithms. You can see that you have an array of numbers, and then you have this method in the package called chunked by a predicate, and so you can say that you want all of the subsequences that follow the predicate that the element on the left is less than or equal to the element on the right. So basically you want to have 10, 20 as the first subsequence, actually 10, 20, 30 as the first subsequence, then 10, 40, 40 as the second one, and 10, 20 as the third one. And as you can see, this is what this function does. So not something that you need every day, but if you end up being in a case where you do need this to implement what you have to implement, you're definitely happy that you don't need to implement it by hand, because implementing this by hand, it feels more like a lead code problem or a whiteboarding problem than the kind of thing that you're used to writing when you're writing your typical iOS app level code. It feels more like data structure and algorithms, to say it this one actually. Swift algorithms is definitely about data structure and algorithms. I mean, like the word algorithm is in the two, so that's a strong hint. I see a few people in the chat. Welcome everyone. So Frank, you say this package is awesome indeed. If you have some example of function that you have used in real world application, please let me know. I would love to know about it. I'm realizing that I've moved the window on the live stream without realizing it. Sorry. Let me also put myself in the corner and make myself a bit smaller because I don't want to cover the code. That's not like the code is way more important than me in this live stream. Okay. So let's get started. The first category is about combinations and permutations. So combinations of count, combinations of particular sizes of the elements in a collection. So let's see. And yeah, I didn't thought to mention it, but most of these functions, and even maybe all of them, if I believe what they say in the overview of the package, is that they are meant to be applied to sequences and collections. So that's why you can see them, basically they are declared in an extension of either sequence or collection. I'm just moving the window a bit so that I'm sure that I don't cover the content. So something like that. I have also an instance of Xcode open in case we want to try some code. So we'll see if we need it or not. And you can see there are also links to the source code. So here I'm just going to have a look just to see where it's declared. But you can see that it declares some kind of data structure, so this struct combination sequence, and then there's an extension to make it conform to sequence, okay? And then there is the extension to collection where we will find the actual implementation of the method. I won't cover the implementation itself because it's very low level, and I feel like it's not like the most interesting thing to cover. However, I did want to highlight the fact that you have links to the source and also the test. So that can be very interesting if you're wondering how such methods are tested. Can be also a very interesting read. But let's check. So these combinations. So it's a type that computes combinations of a collection's element. So the combination of count method returns a sequence of all the different combinations of a collection's elements, with each combination in the order of the original collection. So you have an array of 4 elements, so 10, 20, 30, 40, and then you iterate over all of the combinations of count q, and so it's going to generate all of the different ways to take q elements from this collection. So you have 10, 20, 10, 30, 10, 40, 20, 30, 20, 40, and 30, 40. So it's like, if you ever did, I don't know how you say it in English actually. There is a branch of mathematics which is about like counting the number of stuff in sets, and it's tightly linked to probabilities. I'm not sure how it's called. You know what? I'm just going to open a Google window. I'm just going to ask Google, how is it called in English? Okay, so it's called enumeration, apparently, in English, this branch of mathematics. If you're wondering, in French, it's called dénombrement, which is about like numbering. In a way, it's like putting a number on something. And so it's something that you might be very familiar with if you've ever followed course on that. And if you did any probability, you probably had a course on it. So there is this. And then what do they say here? The combination of elements are presented in increasing lexicographic order of the collection's original ordering. So the fact that it follows the order of the collection. Values that are repeated in the original collection are always treated as separate values in the resulting combination. So if we have 20, 10, and 10, then you get 20, 10, 20, 10 again, and 10, 10. Because with respect to this number of combinations, these are two different values. They just have the same value, but still, it's an array of 3 elements and not an array of 2 elements. Okay. And then here they say, given a range, the combinations of count method returns a sequence of all the different combinations of the given sizes of a collection's elements in increasing order of size. So not only can you ask for the combinations of count q, but also to ask for all of the combinations of count q through 3. So then it gives you first all of the combinations of count q, so what we saw before, and then all of those of count 3. So it can be very interesting. I mean, typical example would be you're writing an app to help people learn about probabilities. That's a great way to teach probability. That's a great helper. Maybe if you need to compute values for probability computations, maybe taking the count of this could be useful, even though it's probably not the most optimized way of doing it, because there is a formula, there is a closed formula that gives you this count without having to enumerate everything. So actually, no, it's probably a terrible way of doing it. But if you ever need to generate this kind of permutations, it can be super useful. I'm wondering, if you want to take a random combination, does it make sense to call this and then take a random element in the combination? Maybe also it's not the most optimized way of doing it. I'm not sure, but it could be an option. And what do they say for the detailed design? They say that the combinations of count method is declared as a collection extension and returns a combination sequence type. Okay, so we have the declaration of the method right here. And since the combinations sequence type needs to store an array of the collection's indices and mutate the array to generate each permutation, combination sequence only has sequence conformance. Adding collection conformance would require storing the array in the index type, which would in turn lead to copying the array at every index advancement. Combination sequence does conform to lazy sequence protocol when the base type conforms. So you can do it in a lazy way, so that if you like, for instance, you want to compute the combinations but only take the first 5, I guess this could help you not compute everything ahead of time. Okay. This part about collection conformance, I won't lie, I didn't understand fully what I read. So they say that, okay, combination sequence is a sequence, so it means that you can read from it, you can iterate from it, but you don't have access. You cannot you cannot access it using a subscript and an index rather. And the reason is that it would require storing the array in the index type. I'm not sure what it means, storing the array in the index type. But basically, what I understand is that they say that it would mean that you will need to do some extra steps every time, and so it might not be the most optimized. I won't go into the details of it because, once again, the goal is more to have a broad view of all of the functions in this package and not go deep into how each of them is implemented. One great thing that they talk about complexity, so knowing how costly it is to call the function. So calling combinations of count accesses the count of the collection. So it's an O of 1, so a constant time operation for random access collections, or an O of n, so linear operation otherwise. So if it's a sequence, creating the iterator for a combination sequence instance, and each call to combinations sequence iterator.next is an O of n operation, because you need to go over the entire array, I guess. So creating the iterator and each call to next is a linear operation. So what does this mean? Why is it a linear complexity? I'm just trying to grasp it, because you have, so when you make a call, basically it needs to, if you say, like, for instance, combinations of count 3, it needs to manage 3 indices, and then it needs to move along the last index. So I guess, what is n actually? They don't say what is n, but I guess, I don't know if n is the size of the collection or if it's the value here that's passed as an argument. Because, so yes. Oh, okay. Okay, so, okay, because it's a sequence, then if you want to know the, yes, that I agree. A sequence, you can't know its count without iterating on it. Actually, sequences in Swift, they can even be infinite. So you might, actually, yeah, when, if you iterate over the sequence and it ends, you can know its count. But I'm wondering, is the property count defined at the sequence level? Because in Swift, typically, you can implement the Fibonacci sequence and it will never end. So I'm wondering now if the property count is defined on sequence in Swift or not. You know what? Let me go on Google and be like Swift count, for instance. So it's defined on array, yes, but is it defined on something else? Yeah, it's available. We agree. It's available for collections, collections only. Okay, and so here when you create the iterator, I'm trying to understand why it's linear. I mean, I understand if it's linear in the size of k here, because you have to advance the last the index. Ah yes, but it makes sense because if here this is a sequence, then to know the count, okay, I think I get it. It's because you need to know the count of this, and so to know the count of this, you need to iterate over it. Okay. I'm wondering now why this information is not cached, because since since the array is immutable during the computation, you could compute the count a first time and then use it as a cached value. Actually, now I want to look to see if it does it or not. Ooh, that looks complex. That definitely looks like some lead code problem. Okay, I'm looking that it's already 20 minutes in the live stream, so I need to go over the functions and not just spend too much time dwelling on one. So I will leave that aside. What do they say next? They talk about the naming. So the parameter label in combination of count has the best match for the Swift API design guidelines. A few other options were considered. So when the standard library uses of as a label, the parameter is generally the object of the operation, as in type of and first index of, and not a configuration detail. So that's why it's like combination of count and not combination of just of. The count label typically indicates the count of the resulting collection, as in the repeat element count function or the string repeating count initializer. And k is used a term of art for combinations and permutations, but isn't widely used in programming context. I love that they give the rationale behind the naming, because as you know, naming stuff is hard in computer science, and so it's great to see that they give this rationale. And also there is a comparison with other languages, and they say so Rust, Ruby, and Python all define functions with essentially the same semantics as the method described here. So that was for combinations. There is, of course, the closed cousin of permutations, of combinations, which is permutations. So a method that computes permutations of a collection's elements or a subset of those elements. So the permutations of count method, when called without the of count parameter, return a sequence of all different permutations of a collection's element. So here, for instance, 10, 20, 30, you have 10, 20, 30, 10, 30, 20, 20, 10, 30, 20, 30, 10, etc., etc. What's interesting is that I remember that the count of the number of permutations of an element of an array of n element, I think, is factorial n, which is an extremely big number. So I think the complexity part will be interesting to read. I think a long time ago I also knew the algorithm to compute all of this. I'm wondering how you can implement this algorithm, because basically what you want is to generate all of the permutation of the indices, and to generate all of the permutations. I'm sure there must be a way to write, for instance, a recursive algorithm where like you change all of the values for one index and then you apply it recursively. Trying to see if, yeah, it's a bit complex once again. Okay, so you can also pass a value to of count. So if you pass the value 2, for instance, then you get all of the permutations of size 2. So it means 10, 20, 10, 30, 20, 10, 20, 30, 30, 10, 30, 20. So I'm trying to understand what's the difference between the permutations and the combinations, because here you see like you have these 6 values, and in the other case, when looking at the combinations, oh okay, no, oh okay, it's because in combinations you like 20 20 10, you don't have also 10 20, but permutations you allow repeats basically. Yes, so you have 10 20 but also 20 10. And same thing, if you did some probabilities and enumeration, you probably remember, because it's like typically they tell you, okay, what's the probability of if you pick like something at random, a ball at random in a box, and then there's a question of like on the next draw, do you put the ball back or not? And that's when these subtleties come into play. Okay. So here they say that the permutations or partial permutations are generated in increasing lexicographic order of the collection's original ordering, rather than the order of the element themselves. So just for the combinations, the first permutation will always consist of elements in their original order, and the last will have the elements in the reverse of their original order. Values that are repeated in the original collection are always treated as separate values in the resulting permutations. So exactly what I was mentioning just before. And yes, so if you recall correctly, it's like, yeah, exactly. It's like factorial of n over factorial of p times n minus p factorial. Yeah, it's the kind of also is a formula that you find in when you want to do if you have like a plus b to the power n and you want to develop it. That's also you find this in the formula. Okay. And here they say to generate only unique permutations, use the unique permutations method. And so here, so now I'm wondering what's the difference between the unique permutations and the combinations. What's the difference between the two of them, actually? Because here, yes, there are only 3 unique permutations. So yeah. Let me reopen the combinations. You know what? This is when the fact that I do have Xcode open is going to come in handy. So let's import algorithms. Okay, we have our array, and we are going to print numbers.unique permutations, and we are also going to print numbers. Wait, it seems that yes. Let me make it in a way where you can see everything. Yes, that should be better. All right, numbers dot combinations of count and free, and let's see what do we get. Build failed. That's not off to a great start. No need to sign. I want to run locally. Okay, so you're saying with permutations, you get all possible orders, whereas with combinations, you only get one. Actually, it will be way easier. Okay, yeah, I need to do a for. Yeah, because since it's lazy, until I've actually called for the values, they are not computed. So actually, I need to do the for loop. Okay. Oh, yes, because here they added some repetitions. Okay. So let me do that. So print combinations. Then, so here I'm gonna want this for combination in print combination like that. And then here I'm gonna want to do permutations, and for permutation in unique permutations, print permutation. Okay, let's run that and let's see what we get. Okay, so combinations we get only 10, 20, 30, and unique permutations we get 10, 20, 30, 10, 30, 20, 20, 10, 30. Okay, okay, so we get way more than these. And if I had just done permutations, oh, okay, in that case, permutations and unique permutations, they are the same because there are no duplicates. But if I do 20, you know what, actually, I'm gonna do all three of them so that we can test everything. So unique permutations like that. Okay, so combinations of three, there is only one, 10, 20, 20, okay. Permutations, there are 6 of them. And unique permutations, there are only 3 of them because I have the 20 duplicates, which means that you can see here, these two permutations, so 10, 20, 20, they are duplicates. And so here it only appears once. So that's the difference. It does feel a bit confusing when you're not used to working with that in your everyday work. Of course, if your everyday work involves these subtleties, it looks much more familiar to you. But when it's not the case, it always feels a bit confusing because you need to make. You just need to make the terminology make sense, basically. But good to know that we can cover all the cases. Okay. And so given a range, the method returns a sequence of all the different permutations of the given sizes of a collection's elements in increasing order of size. So you can ask all of the permutations from 0 to infinity, and so you will get the empty array, then the permutations at 1 element, 2 elements, 3 elements, etc., etc. And so for the detailed design, the permutations of count and unique permutations of count methods are declared as collection extensions and return permutations sequence and unique permutation sequence, very similar to the combination ones. Since both result types need to store an array of the collection, okay, it's the same thing than before. And for complexity, so calling permutations is an O of one operation. Creating the iterator of a permutation sequence instance and each call to next is an O of n operation, and calling unique permutations is an O of n operations. I guess because to remove the duplicate values, it needs to go over all of the values. I guess that's probably because it must turn the array into a set, which is the linear part, and then it's linear every time you create the iterator and call next to it. Naming, they have the same logic than for the previous functions, so the combination function, which makes sense because they are closely related. And comparison with the other language. So in C++, the algorithm library defines a next permutation function that advances an array of comparable values through their lexicographic orderings. This function is very similar to the unique permutation of count method, and Rust, Ruby, and Python have the same thing. And you're right, more like an ordered set because you want to keep the order. That's a good point. And we'll see a bit later on, but I saw that there are also a method to create unique values in this package. So I'm curious to see if it will like relate to what we just saw. And here, you're saying unique permutations, all unique arrangements of elements, particularly useful when there are duplicate elements in the set, combinations, selection of elements where the order does not matter. Absolutely correct. A great question from Wilfried. In which context would you expect this permutation algorithm to be the most used? I would say in an iOS app, I think this makes maybe more sense on the back end. In a way, because it can make sense to make this kind of computation when you need to implement some business logic that needs to deal with randomness, for instance, or if you want to do some matching. Typically, games also often need to do that, but it's true that often the logic for it is on the back end. But remember, this package, you can use it with Swift on the back end also. But typically, if you wanted to implement some gaming logic, imagine like you want to do a card game. Typically, you want to implement a card game, then having that kind of function to generate permutations of the cards that like the player has in hand, or to generate like the starting point in a game, for instance. That could be very useful for this kind of apps. And typically, you have many apps on the App Store which implement all of the basic card games, and since they don't have a backend, they are meant to be played offline. I guess they need to implement some version of this in their own logic. But it's true that typically, if you have an app that's about I don't know, like maybe there are apps where it makes sense to do that on the backend when you want to associate, I don't know, like I have no idea the kind of apps. Maybe for delivery, maybe it could make sense for delivery to have something like that. I'm not even sure if it makes sense for delivery, to be honest. Like I was saying, I never had to use this in an actual app, so it's very hard to find an actual use case where it would make sense. But I don't know. Let's say I'm gonna say something very basic, because I'm sure it doesn't work like that. But let's say like you're a dating app that wants to match people at random. Maybe that could be a way to do it. For instance. So yeah, data science could also use it. And yeah, if you use Vapor, since Vapor is Swift, I think you can import the package and use it with Vapor. I don't see any reason why you shouldn't be able to do it. And definitely, I see that making more sense in the backend for your regular app, except for games which have a natural like need for it. But if you need to implement game logic, you also want to look at, I think it's GameKit. There is a framework in iOS that implements like game engine logic, and it might be also, it might actually implement what you want, just like it might implement what you want without you having to implement the whole logic, because this is quite low level, and it's just a basic operation that you need to use in order to implement a more complex logic. But GameKit, if it's the correct name, has quite a high level set of functions. Let's move along, because it's already half an hour that we are inside, and we only covered two functions. You know what? I'm trying to think. Maybe I should just open all of them in tabs. Okay, so permutations, we've already covered it because it's the same article actually. So here we have the rotate and stable partition. So they are mutating algorithms. So one about in-place rotation and one about a partition. Okay. Let's start with rotating. So rotate to start at, it's a mutating method that rotates the elements of a collection to new positions. So here we have this array and it calls on it rotate to start at. And so you have P here. So it mutates and returns a value. And what it does is that now number, it's 30, 40. Okay, so it's like everything that was after, that was like before index 2. So these 2 were pushed at the end. So it rotated the elements in the array. And then here you have this syntax where it says, okay, P equal for minus minus, I'm not sure what it means, number of P equal 10. I'm not sure what this syntax means, to be honest. I understand the rotating part. I think this might be useful. I know that rotating is something that you often need when you implement binary trees. I know that you can also implement binary trees using arrays, so I'm not so sure if it's a way to. I don't think it's a way to rotate a binary tree implemented using an array. To be honest, and this syntax. So here you have for. I don't understand what this for is. Oh, okay. I think it's for minus. So the value numbers for P. But it's the equal 10, which I don't get. Yeah, I don't get this part. I get the idea that you have. So you're saying P is the index of the new first element relative to the initial array. Okay, so that makes sense. That makes sense. So P here, the new first element is 30, and so P would be 3. And so here it says P equal 4 minus numbers for P equal 10. I just don't get this. Because here this evaluates to a Boolean, and here there is a minus a Boolean. So that's what I don't. Oh, okay. I think it's just something to separate. Okay, it says. Okay, it's like what happened. So following this call, numbers is equal to this new ordering, and P is equal to 4. So 1, 2, 3, 4. So it means that, so actually 0, 1, 2, 3, 4. So P is the index in the new, in the mutated array of the first element of the previous state of the array. And then numbers of P equal 10. Okay, so this is not a minus minus, it's just like a semicolon. It just means like these are 2 different pieces of information. Okay, now I get it. It's not like a weird subtraction. Okay, makes total sense. Thank you. And yeah, rotation could be useful if you have a queue and you want to manage that queue. Absolutely. And so they say to work around the copy and write / slice mutation problem for divide and conquer algorithms, which are the idiomatic use case for rotation. This also includes variants that take a range. So when it says also rotating, maybe it could be, I don't know, like, I know that there are some algorithms, yeah, when you need to, I'm thinking typically, I don't know, when you do quick sort, we need to partition the array in 2 parts, but I'm not sure that you do this kind of rotation. And you can also rotate with a sub range to start at. So what does it do? So here, sub range, yeah, this one is really weird to understand. Because here you have like 10 moved, 40 moved, and the other didn't. And I don't understand like the logic for it, to be honest. I think it's safe to say that this stuff, unless you need it, you won't it's not the kind of stuff that you're going to try to shoehorn into your app because there is no fun in trying to do it. I'm sure it's useful if you have the right problem for it, but here, honestly, without being used to handling this feels very obscure. Let's look at the detailed design. So this adds the two mutable collection methods shown above, so rotate to start at and rotate subrange to start at, okay? And so complexity, rotation is an O of n operation, where n is the length of the range being rotated. The bidirectional collection version of rotation significantly lowers the number of swaps required per element, so rotate would need to be a mutable collection customization point were it adopted by the standard library. I'm not sure what bidirectional collection is. I guess it's collection that you can iterate from both from the start and from the end. And they say that it makes the number of swaps much slower, much smaller, because maybe there is a way to like reverse the start and the end, like inverse the start and the end, and this way you get something that goes that does the result like faster. I'm trying to see here how it would work. To be honest, I like the deep like data structure and algorithm knowledge to understand like the details of what's being said here. And so for the naming, so the index parameter has been proposed as shifting to start in the past. This version uses the to start at label instead. Shifting to start introduces the idea of a shift, which can sound like shifting just that single element at the beginning of the collection. For the range-based overloads, the label could be omitted. That is, instead of using subrange, the method could be called as number.rotate the range to start at. But the label is included here for consistency with other range-based mutating methods. And other languages, C++ has a rotate function with similar semantics to this one, and in Ruby, you can rotate the elements of an array by a number of positions, either forward or backward, by passing a negative number. For zero index collection, forward rotation by, for example, 3 elements is equivalent to rotate to start at 3. Does this support negative values? Let's try and test it quickly. So I'm going to change the code here. I'm gonna say -2 instead, and then I'm going to print numbers. Oh, like that. Fatal error. So you cannot do backwards rotation. You get a crash if you try to do that. So don't do it. But I was telling you at the beginning that I want to try and make like a top 3 or a top 5 list of functions that could be useful for any iOS developer. This will definitely not make the list, because unless you need to work on something very specific, implement, I guess, some specific algorithm that needs this rotation, I don't think you would ever need it. Or to say it differently, I've been able to work on apps for more than 10 years, and I've never needed to use it at any point. So it feels way more like a very low level thing. And then we have partition. So methods for performing a stable partition on mutable collections and for finding the partitioning index in an already partitioned collection. So maybe this is the kind of stuff that can be used when you want to implement a merge sort, for instance. I'm wondering if it could be the case. So they say that the standard library's existing partition by method, which reorders the elements in a collection into 2 partitions based on a given predicate, doesn't guarantee stability for either partition. That is, the order of the elements in each partition doesn't necessarily match their relative order in the original collection. So I guess, if I'm correct, and this can be used to implement merge sort, if you don't have a way to do stable partitions, then your implementation of merge sort won't be stable also, and sometimes you need to have a stable sort for specific algorithms. So these new methods expand on the existing partition by providing stability for one or both partitions. So you have an array, 10, 20, 30, 40, 50, 60, 70, 80, okay? And then you do partition by, if it's a multiple of 20, and so at the end you will have P1 equal 4, and you will have numbers is 10, 70, 30, 50, 40, 60, 20, 80. I don't get how the partition is made. P1 would seem to say that because this is not a multiple of 20, this is 1. Oh, okay, so it creates two partitions. The first one being the elements who are not multiple of 20, and then the elements which are multiple of 20. And so 4 is the index of the first element that match the predicate. So from 0 to 4 minus 1, so 0, 1, 2, 3, it's what doesn't match the predicate, and then it's what matches the predicate. Okay. And then there is so this is the existing partition, and so stable partition, what does it do? Stable partition, it does, oh, okay, you can see that, yeah, the order is not preserved. We have 10, 70, 30, whereas the actual order is 10, 30, 70. And so here we have 10, 30, 50, 70, and then 20, 40, 60, 80. So the P, the return value stays the same, but the partition is now stable. What's interesting is that here, okay, no, I was about to say like this one was stable, but no, 20 is not in the right position. So both were unstable. Oh, I missed your message, Frank, about the fact that oh, so I don't have the hour for your comment. So you're saying if you look at the implementation, you'll see that in most cases nothing is moved in the array. Very efficient. So do you mean for what we're talking right now, the partition, or for what we were discussing before, which was the rotation? And so we're just going to keep moving on that part. So let's say, since partitioning is frequently used in divide and conquer algorithm, we also include a variant that accepts a range parameter to avoid copying when mutating slices, as well as a range variant, range-based variant of the existing standard library partition. Okay. Okay, and you meant about the rotation. Yeah, I guess for the rotation, I can kind of understand why you don't need to move something, because since it stays like contiguous in a way, maybe you can do it by taking like two sub collections and just changing, like remapping the indices. But you don't need to change the array itself. Your rotation can be just a different view of the same array. Let me know if I got it correctly or not. And then there is this thing, so the partitioning index where method returns the index of the start of the second partition when called on an already partitioned collection. Okay, so this is a way to get the value P in the case. Okay, cool, I got it correctly. Thanks for confirming. Okay, so here it's like, here of course you have the value P, but let's say that you don't have it, but you have this array and you want to get the value P, and because it's already correctly partitioned. The thing is, if you were to replace here 60 by 70, for instance, what would you get? Maybe you would get P equal like the last element, I mean the count of the last element, because it's not partitioned actually. You know what? Let me just try this really quick. I'm really glad that I opened Xcode with the package already imported, because it ends up being super useful. So here I'm gonna say print P, and let's see what we get. So we have 4, which makes sense because it's here. And now let's switch 60 and 70. So now it's no longer partitioned, because here we have a first chunk which doesn't satisfy, then this chunk satisfies, and then this one no longer satisfies also. And so what do we get? So it's weird that we get 3 this time, even though here, like this here, doesn't satisfy. So it tells me that here there is indeed a partition that starts, but it doesn't go up all the way until the end. So here, to be honest, I didn't expect to see this result. this feels a bit weird, but maybe I understood the way this works incorrectly. Let me try and do, for instance, numbers of, so like that, and try to print it. Yeah, there are values here, 70, like shouldn't be here. So here I'm a bit confused by this one. I can't imagine that there is a bug in this. It's probably that I didn't understood it like correctly, but let's see. Oh, okay. Okay, so I think, yeah, the collection must already be partitioned according to the predicate. So it's like you have this collection, you promise that it's already partitioned, you promise that this is the predicate according to which it's partitioned, and now it allows you to find the index. Okay, but basically I guess what it does is that it must probably like iterate over the array and say, okay, this is the first value where this is satisfied. Like it doesn't check that it is indeed partitioned. So what does it do? Okay, so it's trying to do like some kind of it seems like it's trying to do some kind of like bisection in order to find the place where the array partitions into two, which actually makes sense. And it's even more yeah, it's absolutely that's the English word, binary search. I was also thinking of dichotomy, which I think is also valid in English, even though binary search is definitely the correct wording. And yeah, you could do it by doing a linear search, but since you have the guarantee that that the array is first the values that don't match the predicate and then the value that match the predicate. So to say it otherwise, you can represent the function which is a function of the index which says matches the predicate or not, and this function is guaranteed to be in monotonous and increasing, because it will be 0 first, then move up, and then be 1. Try to do something with my hand, but since I'm in mirror mode, like 0, then 1, and then it stays at 1. So it's the same logic than when you do git bisect to find a bug, because the hypothesis is that a specific commit introduced the bug, and before the bug wasn't there, and after the bug was, before the bug was never there, and after it was always there. If a bug that was introduced and then removed and then reintroduced and everything, then git bisect won't be as efficient. And yeah, absolutely, this is log n versus being O of n if you were to just go over all of the values. So I'm glad that I was still able to recognize binary search at a glance. At least I still remember that part. Okay, and so it also explains why it wasn't working in my case, because I had broken the contract of the function. Okay. And then they say that the standard library's existing filter method provides functionality to get the elements that do match a given predicate. Partition by returns both the elements that match the predicate as well as those that don't as a tuple. So partitioned by, okay. And so it gives you, so basically it returns the two partitions, but as two different arrays in a tuple. So that could be useful, but since it already returns the index and the mutated array, you could compute it yourself just by computing the two subarrays. So this is more of a convenience method than anything else, but kind of nice to also have it. So they say that it's all declared as extension to mutable collection, all right? And complexity. So the existing partition is an O of n operation, so the one that's in the standard library, where n is the length of the range to be partitioned. while the stable partition is O(n) log n. Both partitions have algorithms with improved performance for bidirectional collections, so it would be ideal for those to be customization points where they to eventually land in the standard library. Partitioning index, where is a slight generalization of a binary search and is big O of log n, so logarithmic, as we just covered. And so it's a logarithmic operation for random access collections, and O of n otherwise. Partitioned by is an O of n operation where n is the number of elements in the original sequence. I guess it's the case because, is it stable, this one? It's not easy to know with the example that they gave, but it would make sense that this one is faster because in the first one you're still having like one array, and so you need to swap elements in the array. Whereas here you just need to iterate over this, and then you say, okay, if it matches the predicate, then it goes into the first result array. Otherwise, it goes into the second. So that makes sense. And then in other languages, so C++, you have something similar. And they say, and notably in the C++ implementation, the result of partitioning has the opposite polarity, with the passing elements in the first partition and failing elements in the second one. So I guess this is more about like a convention, and there is no clear advantage of having one versus the other. Or there might be actually advantages. Like if it happens that people more often, for instance, I don't know, like more often use like... when you have something that is as generic as C++, I guess anything has a performance impact at some point, just because of the scale at which the system is deployed. You know, like I don't know, like typically, I'm trying to find an example in everyday life just to illustrate what I mean. I don't know, like typically, like you are like tapping a phone number, so on your phone. If all of the numbers are further apart, then your hand needs to move a lot. That's not a big effort. But if it's the case for everyone in an entire city, then all of these small efforts, technically, they end up like burning a lot of calories when you do the sum of it all. It's a terrible example, but it gives the idea that even something that is super tiny as a difference, if it's in an algorithm that's deployed on virtually every computer on the planet, then in total, like the sum, if you have 1 microsecond, but it's on a billion computer and it runs 10,000 times a day, maybe in the end it makes a big difference in total. Maybe I should have stopped this line of thought also way earlier. And in Rust, they also have a partition method which returns separate collections of passing and failing elements, so similar to the partition by, and partition in place, which matches what Swift already has. Okay, same thing here, to be honest. Partition, I'm not sure that I would have a big use case for it. Okay, I'm gonna try to move a little bit faster because we still have a lot of ground to cover. So, chain. Concatenate two collections with the same element type, one after another. I thought that the plus operator could already do that in Swift, to be honest. So I'm looking curious to look for the advantage. So this operation is available for any two sequences by calling the chain method. Unlike placing two collections in an array and calling joined, chaining permits different collection types, performs no allocations, and can preserve the shared conformance of two underlying types. So typically, I guess what it does is that under the hood, it just like joins the indices in a way, but it keeps like the collections themselves, and it doesn't reallocate everything. So it's kind of like a way to stitch things together, but without actually moving stuff in memory, which the plus operator definitely doesn't. I think the plus operator... Let me check that you can indeed do this plus operator. So 10, 20, 20, 30, and plus 40, 50. Yes, you can do it. It's a valid syntax. Okay. So detailed design, the chain function takes two sequences as argument. And since you can take two, you could just call it twice and then take 3 and call it 4 times and call it 3 times and take 4, etc., etc. The resulting chain to sequence type is a sequence. So very similar to when you call zip and you get a zip to sequence with conditional conformance to collection, bidirectional collection, and random access collection. So which means that if the sequences that you pass are themselves collection and the result will also be a collection, same thing for bidirectional collection and random access collection, when both the first and second arguments conform. And for the naming, so these functions and types name match the term of art used in other languages and libraries. This operation was previously implemented as a sequence method named chainWidth and was switched to a free function to align with APIs like zip and product after a lengthy forum discussion. Alternative suggestions for method names include appending content of, followed by, and concatenated to. Followed by is interesting. And for other languages, so there is a chain method in Rust, and Ruby and Python, they have iter tools that both define a chain function. Okay. And Frank, you're saying all these non-copying algorithms are especially useful on embedded devices where memory is a scarce resource, and that's what you're doing in Swift. Yeah, that makes total sense. And also, I guess it makes real sense when you're dealing with large collections, because when you have arrays of 3, 5 elements, the difference between creating a new array and using chain is not obvious. Actually, it might even be possible that for small enough arrays, the overhead of using chain, if you're only going to iterate over the result once, it might be less efficient to use chain than to use the plus operator. I'm not sure, but it might be the case. But if you have very large, or rather large enough sequences with respect of the amount of memory that's available for you, then indeed it could definitely make sense. Definitely not something that you would find at your typical app level in your UI level code. Rather, typically I don't see myself writing this in the middle of a Swift UI view, for example, but I can imagine this one being used in the case where you have two large arrays, and at some point you need to iterate over the both of them, but you don't want to add them together because you don't want to create this new huge array that will take a lot of memory, that will take time to allocate, to copy the values, and etc. So this one, I'm going to put it into my reading list because I think this is a candidate for this like a top 3 or top 5 of potentially useful function for any iOS developer. Because you might need it, and even if you don't, then it shows you that actually behind the plus operator for arrays that we have in Swift, there are other alternatives which have different performance trade-off, and also being able to be aware of that when you're not. I also find it like worth something that's worth sharing. Then we have cycle. So iterate over a collection forever, or a set number of times. That's interesting. So cycle times provides a more expressive way of repeating a collection's elements a limited number of times than combining a repeat element count and joined. Okay, so like this will iterate forever, I guess. And okay, so it can be interesting if you iterate over a zip and then one of the operands is a finite set of values and the other one is something that you actually want to iterate. So that can be super useful to have this cycled right here actually. And here, so cycle 3 times, so it will do 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, so this one, especially this example right here, can be useful because let's imagine that I don't know, like you have I can see it, for instance, as being a way to use this rather than to use the modulo operator. Let's say that you have a game, once again, you have like 9 players and 3 teams, and you want to split the people in the 3 teams. What you can do is that you can have so your enum of teams dot all cases dot cycled for the first operand, and then players dot random for the second operand, and this way you do your matching. And you could do the same by taking the index and then doing index modulo the count of your array in the first element. That could also work, but I see it as a more descriptive API. So that one is kind of nice to know about. Not something that's going to revolutionize your world, but it can make something a bit more declarative when you write it, and that's one of the original goals of Swift. That's pretty nice. So this adds two methods to collections, and so you have a new type cycle sequence, which is a sequence only, given that the collection protocol design makes infinitely large types impossible in practical. Cycle sequence also conforms to lazy sequence protocol when the base type conforms. Okay, so calling these methods is constant, because I guess it just sets up the infrastructure for that, so that when you iterate like there is a counter basically. So that's what's happening under the hood. And for the naming, there's a slight off by one ambiguity around the naming of cycle times, since one can reasonably interpret the number of cycles as including the first run through of elements, so which actually the case, or starting after the first set. So if you say cycle 3 times, does it mean that you say it 1 time and then 3 times more, or does it mean that you say it 3 times in total, and it's 3 times in total here? And they say this ambiguity is present in all the different potential names for this function: repeated times, cycle repetitions, or you could say cycled in total. Cycle in, you wouldn't say cycle in total n time, but you would need like a label before and after the argument, so it doesn't work that great. And they say in Rust you have a cycle methods, okay. Ruby you have one, and Python also. Okay, so this one could also be interesting, putting it to my my reading list. So here we have joined, and I think there is a version of it already in the standard library because I've definitely used it. So it concatenates a sequence of sequences, inserting a separator between each element. The separator can be either a single element or a sequence of elements, and it can optionally depend on the sequences right before and after it by returning it from a closure. So typical example is you have a set of values and you want to put them into a comma separated string, for instance. But you can also put like numbers, you can put like a \n if you're doing that with strings. It's very flexible. But I'm wondering, I thought that I was really sure that there was a version of it already in the normal standard library. That's what that's what's confusing me, I guess. Don't you already have one? Like, oh, you have joined separator already. And here it's like joined by, okay, so it seems to be, there is join and separator, and then, oh, I think the difference is that by here, it can be other stuff. Like, for instance, it can be something that returns the sequence. Okay, so that might be the reason why, because when you do the normal, like, joined, you have the separator, and it can also be a sequence. So I don't understand what it adds more, except that here there is a version where it takes a closure. Oh, there is a version here that takes a closure. That takes, okay, so let's see what this version does. Okay, so here you can do $0, $1, both dot count. So 10, 1, 2. Okay, so you have access to this if you want the separator to be a function of both the collection before it, I mean the sequence before it, and the sequence after it. That's interesting. I can see some cases where it could be useful. It could be useful typically, I guess. So it's not the kind. Usually you rely on iOS for this, but I guess for languages, like I could imagine that there are like natural languages, so like English, French, Arabic, etc. There might be languages where, for instance, when you have two words and there is something in the middle, like a preposition or an and, or something like that, maybe the way you write it depends on like the gender of the word before and the word after. For instance, that could be an example of it. And you're saying, Frank, it returns a proxy, not a new collection. So once again, something that's very efficient. I guess they will mention it maybe in the complexity part. So I'm trying to find examples of when you would find a genuine use case for it. I struggle a bit. I've used the join by, the normal one, a lot of time, but often is to put stuff like a comma, typically, so you don't need to have extra information about the sequences before and after. But I can definitely imagine like cases where it does make sense. I just don't have any that come to mind. But I'm sure if they implement it, there is a need for it, a genuine need for it. And so here, what do they say? Oh no, they don't discuss complexity, actually. But you were saying it returns a proxy. So basically, what it does is that it keeps these things, like it keeps like, I guess it keeps like, I mean, it keeps a copy of them, but since you have copy on write, there is no actual copying happening, and then it interleaves the separators, and simply it keeps all of the logic so that when you iterate over the result, then it says, okay, at the beginning, let's read this array, then let's put the first separator, then let's read this array, then let's put the second operator, etc., etc. And what's nice is that what I described here, it's fairly easy to get a sense of how it must work, because if you had to implement it, I guess we should be able to find a way to do it. I'm sure that there are some like caveats and some edge cases, but we can imagine that you need to have like your array of sequences, or rather your sequence of sequences, your sequence of separators, and then you iterate over the first sequence. Once you've reached the end, you use the first separator, then you move on to the second sequence. Once you've reached its end, you go to the second separator, etc., etc. So implementing this could be an interesting exercise, but don't do it to evaluate candidates, please. Product. So I guess this is the Cartesian product. So a function for iterating over every pair of elements in two different collections. So seasons and then years, and so it's equivalent of doing two nested for loops. Why not use it? I don't know. I'm not the biggest fan of data structure and algorithms for interviews, unless it makes specific sense for what the person will do. But having to implement very low level and complex stuff when the day-to-day work is probably going to be doing Swift UI and calling web services, I'm not the biggest fan of it, in the sense that I feel that the interview should reflect what is the actual job. So if the actual job is working on very low level stuff, then definitely, of course, make an interview that is based on it. But it's when there is this like very weird imbalance of the day-to-day job is typically taking requirements which have already been validated by 3 different people, implementing the UI and calling the web services, and everything is ready, and basically you just need to follow the blueprint, and then you have a crazy hard or crazy involved interview process. I feel it's a bit weird. But if indeed people need to do something that is very low level, or something at the server side where you need to implement some complex business logic that does require familiarity with data structure and algorithm, then yes, it makes sense. So I guess to rephrase it, my message was evaluate candidate based on the actual job that they will be filling, and don't overshoot. That's what I meant to say, I guess. But going back on this topic, so is the equivalent of having two nested loops. You can also implement it with two maps, with two by nesting one map inside the other, which kind of by doing you need to have a flat map. I think you need to have a flat map and the map inside it, which makes sense because flat map and map, they are just like loops in disguise. Or loops are maps in disguise, depending on what you learned first. So nice to have this one. And so when either collection is empty, the resulting wrapper collection is also empty. This is the kind of things where I'm not sure same when you would use it into an app. It can make a lot of sense typically if you're working on databases, for example. But usually if you're working on an app, typically the backend will take care of this and then will return to you like a serialized data, which makes sense simply because this kind of operation, it's better to implement it once in a backend than maybe 3 times, once in the iOS app, once in the Android app, once on the website, and potentially there are different bugs in each of the implementation. And so detailed design, so the product function takes at minimum a sequence and a collection and returns a product to sequence type, okay? So one has to be a collection, but not the other. I guess because one of the two needs to be finite, I guess. I'm not even sure, like, why is there this need? I guess because maybe you need a count for at least one of the two. That might be the reason why. Actually, they say it here, it seems. We require collection conformance for base 2 since it needs to be iterated over multiple times. Oh, that's why, because the sequence, when you iterate over a sequence in Swift, it can be destructive. Like, I think typical example is when reading a file or reading some kind of stream, as you iterate over it, you consume the bytes and you cannot get them again. So that makes sense. Okay. And yes, the first one, the outer loop, you won't iterate over it more than once. So it makes sense. And the product to sequence type wraps the base sequence and collection and acts as a sequence in the base case, upgrading to a collection, a bidirectional collection and a random access collection when both base collection have those conformances. Okay. They don't provide higher RETs like product 3 sequence, product 4 sequence, but now with macros you could write it, I guess. Even though it might be super complex to do it. At this time, to match the standard libraries, zip to sequence type. User can compose multiple calls to product if they would like higher RETs. It had been a long time since I had read the word RET. Complexity, since the product function returns a wrapper type, that call is O of 1, and then it's when you iterate over that you actually have the complexity. And so it's M times N, because that's just the cardinality of the set of the Cartesian product of two sequences of length M and N. Okay. So naming, this function and the resulting collection provide a Cartesian product of two collections. While product is precedented in other languages, the name has an unfortunate overlap with multiplication, where product numbers 1 and numbers 2 could be seen as producing an element-wise product. Okay. But people use the star operator to implement a product anyway. And so you have something like that in Ruby, okay, and in Python, they say that also passing one collection and a repeat n parameter is equivalent to passing that collection n times. Okay, so you can do like a repeat 2, and this way you can like do the Cartesian product of a collection with itself. That's interesting. Even though you can totally simulate it, you can reproduce it with the API that we have right here. So like it's just more of a convenience thing. Okay, now we go into subsetting. This is taking way more time than I would have thought. But here also I think we're going to get into the stuff that anyone can use. And I will try to move it a bit faster. So, compacted. A convenient method that lazily flattens the nil out of a sequence of collections. So I guess it's kind of like doing compact map and then $0 in the closure. That's interesting because this one I used to share GIFs of Swift tips on social media, and at some point I was like, you have like IED that come like easily, and then at some point you're like, okay, what do I do for the next GIF? And I did the compacted, and I think it's the one where people starting to say like, ooh, maybe you're taking a bit too much, maybe you're trying to find an example at all costs. So I was like, okay, maybe I'm going to stop with this format for now, put it on pause, and then resume it later. But it's interesting to see that this is actually implemented in Swift algorithms. I didn't know about it back then. So the new method matches one of the most common uses of compact map, what I was saying, which is to only remove nil without transforming the elements. So collection.lazy.compactmap $0 in the closure. Okay, so I wasn't that crazy for wanting to do it. And the type returned by compacted lazily computes the non-nil elements without requiring user to provide a closure or the lazy property. So it does lazy under the hood, which is a nice addition. Okay. There are two methods overload, one for sequence, one for collection, okay? The sequence version of compacted returns the compact sequence type, while the collection version returns the compacted collection, okay? The collection has conditional conformance for bidirectional collection, okay? And they both have conditional conformance to lazy sequence protocol when the base collection conforms. And I guess the reason why you need to have the two of them, because collection already inherits from sequence, or it's because they want to return a compacted collection. I guess because there are performance reasons under the hood. And naming, they say that the name compacted matches the existing method compact map, which is commonly used to extract the non-nil values without mapping them to a different type. So this one, I think we have the first indisputable example where this is useful for anyone. Now the question is does it make sense to include the full Swift algorithm package to your project just for this one method, which is quite easy to define in an extension? I'm not sure, but at least this one, the use case is much less niche than we saw before with rotating arrays. Why do I have partition? Okay, partition by, but we saw it before, so this one I'm going to skip it. Okay, random sampling. So operations for randomly selecting k elements without replacement from a sequence or collection. So replacement, I think is what I was mentioning before, was where like once you've taken an element out, you cannot take it out a second time. Okay, this one can be useful, I think. So use this method for sampling multiple elements from a collection, optionally maintaining the relative order of the elements. Each method has an overload that takes a random number generator as a parameter if you want to control the seed, for instance. Or if you're writing a test and you want to send a hard-coded seed. Okay. So here it takes 4 elements at random. And related type, so these methods do not rely on additional types. They eagerly select the required number of elements and return an array. So I guess what they do is that they draw a random number. They just keep a list of the numbers already. I mean, they draw a number, then they do a modulo, I guess, for the size of the array. Even though it might not be the best way to do it. Because then, like, I don't know, but like with random number, if there is any kind of bias, it's a big problem. So let's see actually how it's implemented. You know what? Let's see. I say let's go faster, and then I say let's go see the implementation. But so they do. Okay, so it takes an int.random in 0 all the way to remaining count. Okay, then it happens to the result. And then it decreases remaining count. And there is this count to select. So how many do you need to select? Okay. So that makes sense also. And here, So it takes a random number. If that's less than the count to select, then it's going to append it. Otherwise, it does this thing which is form index, but I don't know what this does. Let's just look at random sample, which might be easier than a random stable sample. So, okay, reserve the array, okay. So here, it seems that it's filling a reservoir with the first k elements, okay. And then it calculates the next value. So yeah, it won't return the same element twice. So that's the no replacement part that was mentioned. And so here it gets this next W. Okay. Find index of the next element to swap into. Okay, so it creates the reservoir and then it swaps elements from the array into the reservoir. Okay. So it does next offset, then get the index, and then swap the element. Okay, so it's this next offset where the randomness, I guess, is done. Oh, okay, that's why there is this. Okay, that's why there is this logic, because it creates this like reservoir of like let's say you want 4 random elements, this reservoir of 4 elements, and then it's going to swap elements that are not in the reservoir into the reservoir. But then the question is, the elements in the reservoir can never be selected, I guess. That's the weird thing here. Okay, in the end, it does a shuffle of the result again. But here, so it does random result of j equals self. This is such a... You really need to spend time like going into it. Otherwise, it's so confusing. But if there is one thing that I've learned in the past, is that when you implement this kind of random way of picking elements, usually one of the use case for it might be because from this randomness you get some sense of security by making the behavior unpredictable. That's the case for cryptography, but that's also the case for other things. And so any kind of bias in your randomness decreases the security of your code because it makes it more predictable. Typical example would be at a casino. If you have a way to predict a win even by a few percent above what it would normally be, that might be enough so that you can win infinite money, for instance. So you definitely want to make sure about what you're doing, that you know what you're doing when you implement randomness, especially if it's critical. That was the point I was getting at. And I'm sure that behind this code, which is indeed quite like mindfuck, I'm sure that there is some like mathematical theory behind it to prove that it's indeed correct. So they said the value must always be non-negative for the count. It makes sense. If the count is larger than the length of the collection is called on, then the return array contains all of the elements of the collection and none of them being repeated because there are no replacements, okay? And complexity, so the random sample method uses reservoir sampling, which allows the method to be big O of k when called on a random access collection. When called on a sequence or a non-random access collection, the algorithm requires O of k random numbers and accesses O of n elements of the collection. And the random stable sample method uses selecting sampling, which is an O of n algorithm. This algorithm requires a count of the collection in advance, which restricts its use to collections. A sequence-based version would need to save the elements to a temporary array, which we generally don't want to do for this kind of operation. And also, I guess if you need to save the elements to, oh yeah, because then there is a copy that is involved. Okay. Naming. So the standard element library already declares a random element on sequence, which returns a single random element. The random sample count name is chosen to align with random element, but be more distinguishable than something like random elements. Other names considered include sample and choose. Choose feels very probability theory. Very, very probability theory. Like, what are the how many ways are there to choose 2 elements out of 3? This kind of way of saying it. So they say that it exists in C++ and Ruby Python. Oh, here this is interesting. There is other consideration. So let's look at that. So post-sample shuffling. Simple implementation of reservoir sampling tend to return some of the initial elements in the same order they appear in the array. To avoid this bias, the unstable implementation of random sample explicitly shuffles the elements before returning them. We saw that just before. To see the bias without shuffling, consider the following example that uses a hypothetical random sample unshuffled method. When selecting 3 out of 4 elements from an array, whenever any of the first 3 elements are included in the result, they are always in their original positions. Elements selected after the initial count are in randomly selected positions. So without the shuffle, indeed, they tend to be in their original order. And when you shuffle, then there are way more possible outcomes. And so this kind of bias is what would make the randomness of your code less high than it should be, less high than pure randomness, 100% unpredictable. And so it makes your system more vulnerable. And since only the reducing array is shuffled, this additional reordering only has a big O of k performance cost. Okay. Reproducibility. This doesn't address the ongoing issue of versioning RNG algorithms. It poses the same problem as the existing high-level methods, such as random element using and int random in using, so using a random number generator, in that changes to a sampling algorithm in future versions of the library will change the expected output for replaceable RNGs. While we don't currently make any guarantee about future versions of the stdlib producing identical results, users routinely make that assumption. So the idea is that if you send an RNG with the same seed, you would expect to have the same result. But since the algorithm that implements the sampling might change, actually, you might no longer get the same result because, yes, you're still passing the same random number generator with the same seed, but it's being used in a different way. And here, index-based overloads. Because none of these methods are mutating or have special behaviors based on the underlying collection type, we don't need a separate set of methods for working specifically with indices. A collection's indices typically has the same performance characteristics as the collection itself, so a user can call collection.indices.randomSample to get a number of random indices. And with the new API in Swift that can also take as an input of a subscript sequence of non-contiguous indices, this could be quite interesting. And lazy sampling. The stable version of sampling could theoretically return a lazy wrapper instead of eagerly creating the sample. However, this isn't well motivated and poses some challenges, such as needing to store a copy of the random generator and potentially needing to cache the randomly generated values. Because like if you stop at some point, then you need to be able to resume keeping all of the state. Like you need to save all of the state of where you were in the algorithm. This one could also be useful. I'm gonna put it into my shortlist. So random sampling, we just covered it. Stride seems to be an easy one because there is already similar stuff in Swift, in the standard library. So step over the elements of a sequence element by a specified amount. So this is available through the striding by method on any sequence. So 0 through 10 stride by 2. So you get 0, 2, 4, 6, 8, and 10. Okay. if the stride is larger than the length of the sequence, the resulting wrapper only contains the first element. The stride amount must be a positive value. Okay. Detailed design, the striding by method is declared, okay, on sequence and correction, okay. This part is not necessarily the most interesting one. Okay, here they say that the two lines are equivalent including performance. So if you do stride by 6 or stride by 2, then stride by 3, since 6 equals 2 times 3, then performance-wise it's the same. So I guess this would mean that, yeah, because, okay, there is striding by and stride by. So stride by is the one that you have in Swift. And so what's the difference between stride by and striding by? Like if I do like an array like 1, 2, 3, 4, 5, and then I look at stride, there is striding by. Okay. And then you can call, okay, you can call an additional striding by on it, like that. Okay. But what does it say stride by here and not striding by? Maybe it's just a mistake. Oh, okay, and the one you have, okay, the one you have in the standard library is this one, which is stride from through by, so stride from 0 through 10 by 2, and this will return, okay, yeah, I was confused because I knew that this one existed. Okay, so you have this one, but this one returns, I guess, yeah, a stride through, which is some kind of sequence, I guess. And so this is one API, and this one does the reverse. Like, I mean, not the reverse. They both return the same thing, but here you do it by giving like the bounds, and in the other one you give an actual array of values. So like, I guess you could build this by using this over the indices of the array. That's my guess, and I think it would make sense. Like, you would do like for e in, so you have this array right here. So let's say I have like my numbers like that. You know what? I just want to try it just to see if I can implement some simple stuff. Now that I've seen like super complex code. So I have my numbers like that, and I want to do for e in for I in stride from numbers dot start index, and it's not through that I want, it's to, because I don't want to include the last. No, actually no, it's through. Numbers dot end index by 2, and then I'm just gonna do like print numbers of I, just like that. Let's see. Build failed. Yes, because I forgot this. Okay. Build succeeded. Okay. So, okay. For number in let's write like that. 135, 135. Okay. I'm able to implement simple algorithms. Woo! Okay, so this here conceptually is equivalent to this, but this might be more performant actually. But conceptually, in the inputs and the outputs, it seems to be doing the same thing. Okay, I'm glad that I got to do this one. Okay, complexity. So the call is O of 1, and access to the next value is O of 1 if the question conforms to random access question. Otherwise, O of k if it's a sequence, because you need to go over the values to like consume enough values until you get the one that matches your stride. Okay. Can be an interesting one, but honestly, like if you let me know in the chat if you need to use stride, if you've ever used the stride in Swift, the basic one, because I remember like seeing it in like WWDC sessions, but like maybe 8 years ago, something like that, around the beginning of the language. And I haven't seen it. I don't think I've ever used it, or maybe once and I forgot about it. But stride, I don't think I've ever needed to use it, because most of the time, I mean, sometimes when you will need to do something like taking every other value, I'm thinking maybe you will do it by doing like a call to is multiple off, which might be like a bit easier to read or a bit simpler. So yeah, I don't think I've ever used it. So suffix. This function returns a subsequence containing the elements from the end of the collection until the predicate returns false and skipping the remaining elements. Okay, so this example uses suffix while to iterate through collection of integers from the end until the predicate returns false, in this case when $0 becomes less than or equal 5. So that's interesting. This one, honestly. I think there must be also a prefix one that must go with it. Oh, actually, I think that, yeah, you have prefix while in Swift, and so they did, there is prefix one in Swift, and so they created suffix while, so there is a symmetric for it. Okay. I'm trying to think, in a way, I guess you could implement suffix while. It's not maybe the most optimized, but you could take the sequence, reverse it, then do prefix while, and then reverse again. And I'm wondering if it holds that it's equal to suffix while. But maybe this could work. But this one, yeah, worth knowing. Like, typically, if you ever need to use prefix while, maybe you have a legitimate use case for suffix while. The reason why I think it makes sense to have prefix while and not necessarily suffix while is that having prefix while makes sense. For instance, in the UI, typically, you often have the pattern in UIs where, because there is limited space, typically, imagine that you need to display like colors, but you only have space to display 5 colors. You're going to display 4 colors and then ... to access the full list. Then what you want to do is call prefix to get the first 4, for instance. So that's why I think prefix naturally comes more often than suffix, but it's good to have the equivalent one. Then we have trim. So a group of methods that return the subsequence formed by discarding elements at the start and or the end of the collection which satisfies the given predicate. So you might be familiar with trimming, but on strings, to remove white spaces and new lines, for instance, because there is an API in Swift for that. And so you can do trimming while, and for instance, on a string, trimming while is white space, and it will remove all of the elements at the beginning and at the end of the string that match this predicate. Or if you have an array of numbers, you could say trimming while the number is even, and so it's going to remove 2 and 10 on the first side and 100 on the other side. So same thing here. I think this one, if you were to implement it, you could find a way to do it. It's way less complex. I don't have a clear use case where it could make sense, because the typical use case is around strings, character strings, but they already have a method to trim new line and white spaces, actually to trim characters in a given character set. What do they say here in the naming? Wow, there is a full table of all the different names in all of different languages. Okay. And they say that there are methods with similar operations, the drop first, drop last, remove last, everything like that. Okay, so that's the logic why they call it like suffix while. Okay. Oh, trim rather, sorry. What do they say here? With a lazy filter that drops all white space characters, regardless of whether they are in the string, Besides that, the root trim leads to clearer, more concise code, which is more aligned with other programming languages. So you could say drop from both ends, but they say does result contain the input trimmed of certain elements, or does this code mutate the input in place and returns the element which were dropped? Interesting. So yeah, trimming makes it more clear that it's returning a new value. Actually, they call it trimming, but shouldn't it be like trimmed to like the guidelines from Swift? The way I understand it, it should be like trim while if you mutate, and trimmed while if you don't mutate and return a new value. But trimming, actually, I guess because there are some other like languages that call it like that, but yeah, trimmed would have made a bit more sense. Okay, this one is useful to know, even though, to be fair, I think as a developer, you most likely will need the version for the character string, so that's why I won't put it into my shortlist. Unique, I think, is also very interesting because there are many code bases where you have an implementation of that that uses a set under the hood in order to unique out the values. So it's a method to strip repeated elements from a sequence or collection. The unique method returns a sequence, dropping duplicate elements from a sequence. The unique on method does the same, using the result of the given closure to determine the uniqueness of each element. So here, unique, it only keeps 1, 2, and 3 because all of the other ones are duplicates. Okay. And unique on, I'm not sure what it does actually. They don't show an example for it, but let's look at the test to see an example. Oh, okay, so typically if you want to say like, okay, unique on the first. So for instance, everything that starts with an A, then you only keep the first one and the rest goes. Okay, that makes sense. Unique on, because I was like, since you only get one element, how do you say? But it's more like as if you had a map on the element and you were doing the unique based on the result of that map. Okay. This one, I would say is worth knowing, to be honest, because once again, it's just like compacted because you often end up defining your own implementation. Okay, here I think we're definitely entering the territory of stuff that way more common in code bases. So minimum and maximums, or rather minima and maxima when you do the plural in the Latin way. So it returns the smallest or largest elements of this collection, sorted by a predicate or in the order defined by comparable conformance. So you already have min and max in the standard library, but here you can say like the min three, so the three smallest values. So you could do it by doing min, then removing the min from the array, then recalling min, everything like that, but it's not efficient at all. Whereas you can get the three mins, at the same time. Okay. If you need to sort a collection but only need access to a prefix or suffix of the sorted elements, using these methods can give you a performance boost over sorting the entire collection. The order of equal elements is guaranteed to be preserved. So if you need to sort a collection, but so if you want to sort and then prefix or suffix, then you can use this, and basically it's like it will only compute only do the minimum number of operations to get data that you need, but it won't compute the rest of the sort, which you would have discarded anyway. Okay, and you can control the predicate, the comparison predicate. If you need both the minimum and maximum value for collection, using these methods can give you a performance boost over running min method followed by the max method. So you can do it in a single pass, finding both the min and the max. So here, min and max, it will give you both the smallest and the largest. But you can do min count, max count, but you cannot do min and max with different counts. Okay, interesting. And so complexity, looks like we are in complex territory, definitely. The algorithm used for minimal or maximal order subset is based on Soroush Kanou's research on this matter. The total complexity is O of k log k plus nk, which will result in a runtime close to O of n if k is a small amount. If k is a large amount, more than 10% of the collection, we fall back to sorting the entire array. Realistically, this means the worst case is actually O of n log n. So yes, you can get something that is like much better for small values of k. So how many mins or max values do you want? And then if you ask for too many, then it's going to do a full sort because it's more efficient to do it like that. So there is some benchmark that show how the implementation, so smallest m, behaves when k increases. So sort plus prefix is a line. That makes sense because it shouldn't change. Quick sort base is the yellow one. Okay, and so yeah, it shows that for small numbers it does go faster, except for very small numbers of k, and then at some point it would be indeed more expensive than doing a sort, and you can see the lines crossing here. Okay. And they say here, the algorithms used for simultaneous minimum and maximum is slightly optimized. At each iteration, two elements are read, their relative order is determined, then each is compared against exactly one of the current extrema for potential replacement. So they read two elements and then exactly one. Oh, okay. It's like you take two elements from the array, so A and B, let's say, and then if A is less than B, then you only need to compare A to the smallest element and B to the biggest one, because since A is already not slower, lower, smaller. Since A is already smaller than B, so you know that A cannot be the max because there is already B, which is bigger than him. So B could be the max or another one, but A cannot be the max, it's been ruled out. And B cannot be the smallest, it's also been ruled out. So because you've got this first test, which allows you to rule out each of them from one of the two positions of being min or max, then you only need to compare one to the min and one to the max. And this way you need to do one comparison between the two elements and then two, one for min, one for max, rather than doing four. So comparing the first element with min and max and second with min and max. So you save 1 out of 4 operation, which is quite smart. And when a comparison predicate has to analyze every component of both operands, the optimized algorithm isn't much faster than a straightforward approach. But when a predicate only needs to compare a small part of each instance, the optimization shines through. So this one can seem also quite useful. So I'm going to put it into my shortlist. Okay. So partial sorting, it's what we just covered. Okay, 2 hours, we are getting close to the end. I still need to cover all of this, but I think that the time passing and my voice starting to kill me a bit and this cup starting to be empty are going to motivate me to go a bit faster. So adjacent pairs lazily iterates over tuples of adjacent pairs. So you have numbers from 1 through 5, and it will give you 1, 2, 2, 3, 3, 4, 4, 5. Okay. I think this can be useful sometimes. I mean, I've done something similar when you wanted to iterate between, like, you wanted to have the current value and the previous value, for instance. But then you don't want to have all of the pairs. You just want to have, like, every time you get a new value, you also want to get the previous one. So usually you can do it by doing a zip of the sequence and the sequence dot drop first, for instance. Okay. What could this method be used for? I'm less sure, but I'm sure there are situations where it makes sense. I will definitely not put it in the list of what any iOS developer could find useful, to be honest. This one, I think also if you had to implement it, I would say that it should be rather straightforward, I guess, because it's like you have to have one index and then you build tuples using the index and then the index plus one if it does exist. So 1, 2, 2, 3, 3, 4, 4, 5. So a nice little helper, but this one seems like way less useful than the previous one we just saw about min and max. Let's be honest. Okay, chunked, it's the one that that they show you in the README of the package. So the one that they feel conveys the most the usefulness of the package. I think a colleague of mine used it. For instance, when you have like a set of data and you want to process them like 4 by 4, for instance. And so using chunked by 4, I think he used Swift algorithm to implement this. And so this one, it does have a real world use case because I have seen it happen in an actual iOS app. So it's definitely going into the shortlist. And so you can break a collection into non-overlapping subsequences. And so chunked by uses a binary predicate to test consecutive elements, separating chunks where the predicate returns false. For example, you can chunk a collection into ascending sequences using this method. So it's not only fixed size chunks, that would be chunks of count, but you can say chunks of increasing sequences. So 10, 20, 30, 10, 40, 40, and 10, 20, for instance. What we saw when we look at the README at the beginning. Chunked on, it takes a projection of each element. So kind of like having a map. So here it's going to chunk on the first letter. So it's kind of like doing some kind of a group by in a way. Actually, there is an init of dictionary in Swift which does a group by. Actually, it takes a sequence and the closure to project that sequence onto a value that's hashable. And so it's basically the same logic, except that instead of having a dictionary, you have an array of tuples, which this looks like the key of a dictionary. And this looks like the value of the dictionary. And yeah, as you're saying, Amir, useful for pagination. I think you said the word. That's the word I should have mentioned before. Pagination. Yeah, whenever you need to paginate your data, that's definitely what you want to use. And so chunks of count, I would say, is the one that is the easiest to use because that's the basic use case for taking chunks of the same size. Okay. And evenly chunked, what does it do? So it takes a count parameter and divides the collection into count number of equally size. Okay, so instead of saying I want chunks of size 3, it's saying I want 3 chunks of the same size. Okay. Okay, and the chunk at the start will be longer than the chunks at the end because, like, if you have 15 elements and you ask chunks of 7, since 15 is not a multiple of 7, you cannot do it evenly. Okay. No, it's like no, it's I'm saying something stupid. It's more like, let's say you have 5 elements and you say that you want 3 chunks. Since 5 is not a multiple of 3, there is no way that that you can split 5 elements into 3 chunks of equal size. That's just not possible. And so the larger one will be at the beginning. Okay. All right. I'm gonna go a bit fast on the rest because we still have some ground to cover. But chunks is definitely nice. first non-nil and then you pass a closure. That's interesting. It returns the first non-nil result obtained from applying the given transformation to the elements of the sequence. So here is the first non-nil when you transform the input into an integer using this parsing method, which can fail. So here it should be -5. Okay. So it's like first where. It's just like if you were to do first where with the closure saying different of nil and then having a iflet. Actually, no, the iflet, you also have it here. So basically, it's the same thing, except that you don't need to say different than nil in the closure. Okay. And then you get the result instead of getting the index of getting the value. And okay, here you also need to duplicate the code that's in the closure. So this one is kind of interesting. Okay, yeah, you could also approximate it using compact map, indeed, and calling the first on compact map. So nice to see that it's also a convenience wrapper around the compact map. So this one, I think I will also put it in my shortlist. But they say also that, however, unlike first non-nil and first where, compact map does not start iterating the sequence. So it's going to compute everything, even though you're only interested in the first result. So this could potentially be wasteful unless you use a lazy, but then you need to deal with escaping closures and everything like that. So this same thing, like first non-nil, just like compacted, these two are very interesting to know them, I feel, because they don't like do something crazy that's impossible to implement otherwise. It's quite easy to implement the same feature using your own extension on sequence or on collection, but it provides one implementation that's tested, that's standardized, and so you have less risk of having a small edge case that you haven't handled correctly. So I think this one, it's worth knowing. Like compacted and first non-nil, they are very much worth knowing. Okay, groups element of a sequence into a new dictionary whose values are arrays of grouped elements, each keyed by the result of the given closure. I think the reason why lazy is more that if you do lazy, what they said is that if you do lazy, why can't I wanted to reopen what I had closed, but it doesn't work. It was first non-nil. They say that you cannot throw. So if you have a lazy closure, then you cannot throw in the closure. I guess lazy sequences, they don't support throwing. In a way, it makes sense because the non-lazy version, they support throwing using rethrows, so that if you don't throw in the closure and you don't have to handle the error, but lazy, it cannot use rethrows because it's not calling the closure immediately. And so, since it can't use rethrows, then you would need to handle the error case every time you use something lazy, regardless of whether you've thrown or not. Or then they would need to do a lazy sequence and lazy throwing sequence, like you can see in some packages. So I think that's the reason why. So here, the thing that's weird is that I was pretty sure. So here, okay, you do grouped. You see, let me copy and paste this code because, so you do this, okay? But you can also do dictionary grouping by, and so you could say grouping fruits by this closure, like that. And so let's call it like that. Okay. And then let's print. So fruits. If it's lazy, then I will need to iterate because printing will not do anything, but we'll see that. Okay. So A. Oh, okay. The only difference is that the second one doesn't keep the order, but it seems to do the same thing. Just here. Oh, okay. No, they are both actually. They are both dictionaries. Yes. Okay. So now I'm curious. What's the difference between the two of them? Because these two things, they seem like They seem super super similar. What's the reason for it? Yeah, here it's not clear what's the reason why they define this, because the other the dictionary in it was definitely there before like this was in Swift before they created Swift algorithms. I'm pretty sure of that. So I'm not sure about the reason why. I don't really see a clear reason because you already have it. I mean, the only reason is that the API works on the other way. So you call it on the sequence rather than build a new value from the sequence. But besides that, I don't really see the reason to use it, to be honest. I'm sure that since it's still in the package and they haven't removed it or even deprecated it, let me just look at the source to see if it's marked as deprecated. No. Actually, good thing I looked, because look at the source, they just call the init of the dictionary under the hood. So I think the reason, I guess, that was that they really wanted to have an implementation where you can call it on the sequence rather than create a value from it, maybe because like the way some frameworks in Swift or at Apple are written, and they really wanted to have it, but it's the simplest implementation we've seen until now. Super straightforward. And indeed, there is no clear added value besides just like offering a different way to call it. Okay, so indexed. So what does it do? They say that it's the enumerated method, but pairing each element with its index instead of an increasing integer counter. Oh yes. If you follow my channel, you've seen this method a few weeks ago, like 2 months ago, in the video I did with Natalia Panferova, where she showed this example that doing zip and enumerated, using enumerated to get the indices of a collection is actually a bad practice, because enumerated returns just 0, 1, 2, 3, but this might not be the actual indices, and so indices actually does it. So indexed actually does it. So indexed, it does just like enumerated, except that it gives actual indices, whereas enumerated gives integer values starting at 0. And it's important because if you have, for instance, a sub-array, then it might not start, its first index might not start at 0. So this one, I think it's definitely worth knowing. Super simple, and it can save you from very subtle bugs that might happen like years after you've put the original code into production. Okay, intersperse. Place a given value between each element of the sequence. So you have 1, 2, 3 interspersed with 0. So it's kind of similar. Oh no, we had seen the joined, which is kind of similar in a way, except that joined, you will need to first have like put each element to a collection of its own and then do join. So it's the same thing, but with a single with one less dimension. Like you don't have a collection of collections, you just have a collection. Okay. Interspersed. Okay, that's interesting. Interesting also if you need to work with strings, because I can imagine some use cases where you might want to have this. Okay. And when it's empty, then it does nothing. Okay. So same. I think this one could be useful. I don't see myself using it that many times. Here, this one could be interesting. Typically, let's imagine that you need to implement a UI to input a pin code that people receive. And when they receive the pin code on the paper, it's a dash separated value. Then that might be a way to reflect these dashes dynamically into what's appearing in the text input. That's a potential use case that I have for it. But otherwise, it could be also very useful. For instance, if you're writing tests and you want to kind of like, perturbate your data a bit to see how your code is going to handle it. That could be also interesting when creating test data. So I'm gonna put it into my shortlist also. Then we have KID. So store the elements of a sequence as the values of a dictionary keyed by the results of the given closure. That seems very similar to what we just saw before, which was grouped by. On a key collision, the latest element is kept by default. Okay, so it's a way to turn an array into a dictionary, but if there is a collision, then by default it will keep the latest element, but you can also have a closure to solve the conflict. Okay, so this one is quite interesting. So it's a way to have like a two dictionary in a way. I want to check just how it's implemented to see if it's simple or not. Seems quite simple. Okay, it just iterates over the values in the collection. So nothing too crazy here. Okay, so it's a way to turn an array into a dictionary, which you could also do. I mean, the init with the group by is not exactly the same because here it will keep only one value per key. But it could be useful in some cases. I don't see one that clearly like jumps to mind, but it could be useful in some cases, especially because this resolving conflicts with, once again, you can implement it yourself. It's not that hard to implement. But here you know it's already been implemented, tested, and it's a bit more standard and something that you would implement yourself. Okay, I think we only have 4 to. Actually, no, we actually already covered partition, so I guess it's because, yeah, there was here partitioning index, okay. So we only have a reduction, split, and windows of count. Okay, we're getting close to the end. So reduction produces all the intermediate results of reducing a sequence's elements using a closure. So it's just like calling reduce, except that you also get all of the intermediary results. Interesting. If you've ever used RxSwift, in RxSwift there is an operator called scan, which does basically the same thing. It's like reduce, but with intermediary results. So this can be useful. I see this being useful in a way, not necessarily like in production code, but when you have a bug in your code and you're using reduce, then you can transform reduce into reductions, and this way you can see all of the intermediary results and try to understand what's happening. It might be easier than just like debugging your code. To be fair, also, using reduce can very easily lead to code that is more complex than it ought to be. But okay, this one is kind of interesting, and the idea is easy. It's like, oh, here, look, they talk about scan. So while the name scan is the term of art for this function, it has been discussed that reductions aligns better with the existing reduce function and will aid newcomers that might not know the existing scan term. To be fair, when I first heard of scan, being able to understand that scan is reduced with intermediary results, like the jump is not obvious at all. It's even like totally unobvious. So I'm glad that they didn't like followed with this. To be honest, and they added deprecated methods so that people who are familiar with scan can discover them and then use reductions. That's very nice. Okay. So yeah, this one maybe we put it to a shortlist because it's reduced but with intermediary results. So for debugging, I see a question. So Kyle, you're asking, do you have any tips for getting more familiar with Objective-C? As a Swift developer, my next job involves a lot of Objective-C and hopefully converting a portion of the code base to Swift. That's a good one. What I would recommend is that for the basics, you can look If you can still find it, the code, yes, and the sessions of the Stanford course CS 193P from before Swift, so from 2009 to 2013 or 14, they must be in Objective-C. And if the videos and all the slides are still available on YouTube or on like Stanford EDU, maybe it could be useful. Otherwise, I mean, the website NS Hipster still has a lot of content about Objective-C, but it's more advanced content. But then, I mean, I'm sure that you can find tutorials on like the basics of Objective-C, because Objective-C, I mean, if you know Swift and you know object-oriented programming, like the basics are not that hard to understand, to be honest. Just the syntax is a bit different. It feels a bit like older than modern languages. But besides that, the core concept, like Objective-C, the name kind of means like C with object. It shouldn't be too hard, honestly. It's more a syntax problem, I think, than a concept problem when you already are familiar with object-oriented programming. So just to say, like, don't stress too much about it. Get a hang of the syntax. Maybe try to follow. Maybe like I think it's not called. I think the website is no longer called Ray Wenderlich now, but this website might have like tutorials from back in Objective-C. You can try to implement like the basic tutorials in Objective-C, and it might also be enough to give you like the basics and to give you some starter points. Okay, so we covered reductions. What do we have after reductions? We only have two. So we have split. So split. So we have split, max splits omitting empty subsequences where separator, and split separator, max splits omitting empty sequences. They are a mouthful. What do they do? So you do, okay, so here you create numbers, and then you do split where separator, and so it's either the number is a multiple of 3 or a multiple of 5. That looks like some kind of fizz buzz, I would say. And so you have 1 2, because for 1 2, both, I guess, are false. Then you have, where is 3? Oh, because it's going to omit something, I guess. Where is 3? Because then there is 4. So it seems that as soon as it matches like one of the two, I mean, as soon as it matches the predicate is matched, it breaks. Oh, okay, because it's the separator. Okay, that makes sense. Thank you, Frank. I think you're more awake than I am right now. So where separator? So that's why. Okay, so it breaks the initial sequence into subsequences using as a separator when disclosure returns true. So 1 2, then 4, then 7 8, then 9 goes matches this one, 10 matches this one, 11 matches neither, 12 matches this one, 13 14, and 15 matches this one. Okay, and same thing for the lazy collection. So here it does split, and separator is a white space, and it omits the empty subsequences because here there is the separator several times in a row, and so you have, okay, blanche I, okay, so it separates using the white space. Okay. Okay, might be useful. I'm wondering, I guess there must be already the interesting one is the max splits, for instance, because it could have a need for it, but I don't see like a clear use case for it. And you're saying, wow, you're saying that you got into a fine company as a senior iOS engineer. Good job. Good job. I'm glad to hear that I've been able to help you. Fun fact, but I've never went to any kind of a fine company myself. So I'm glad I've been able to help you get there. And congrats, because it's definitely something that is quite a good achievement. And what's nice is that it's a good achievement. I would say like a 360-degree, because it's good for yourself, for your sense of being skilled, of being accomplished. But you also paid very well, so it's also good like for your bank account. So it's good for everything. So well done, well done. Very glad to hear about that. Well done. And I've lost my train of thought once again. You can see it's almost 10:30 p.m. in France, and I had a big day today, and it's also like a bit hot where I live, and I can see that I'm getting tired, but thankfully there is only one more to cover. And I'm really glad that I've already watched the episode of House of the Dragon earlier today, because I'm not sure I would have had the energy to go watch it after the live stream. So Windows, seems like we have this idea also of moving through a collection with fixed sizes or dynamic sizes. So it breaks a collection into overlapping subsequences where elements are slices from the original collection. So it's kind of like the chunks, but this time it can overlap. So the windows of count method takes a size as a parameter and returns a collection of subsequences. Each element of the return collection is a successive overlapping slice of the given size. So windows of count 2, so you have SW, WI. Okay, so it's like it moves the window across the sequence. Once again, I'm not sure where you could use it. There are definitely use cases for it. Like for instance, I have memories from learning low-level networking protocols where having windows like that can be very useful. So it could definitely make sense. I don't think I have a clear use case for it, but it could definitely make sense to have this windows that go over a sequence. Oh yes, actually, I was mentioning it before, but if you have a sequence of events and you want to have the current event and the previous one, the current value and the previous one, then you do a window of count Q, and I guess that gives you current and previous, for instance. So it could be a use case for it. And guess what? I think we have finished this live stream. So it was 2 hours, 22 minutes, and 22 seconds. Exactly, on the mark. Okay, so it was quite a big live stream, but it will be nice to add the chapters on the replay. This way, it will be very easy to access each of the functions that we have covered. So in the end, let's try to do a bit of a conclusion. So let me make myself a little bit bigger again. So I told you that I had basically never used the Swift algorithms package, and thinking about it, my colleague at work had used it once for the chunks method, but me never. Now I kind of understand why, because many of the methods are very low level. So if you work on low level stuff, like Frank was mentioning in the chat, it makes total sense for you to use it. But if you don't work on that, it makes much less sense for you to use these methods. So that explains why, as a developer, I never really needed to use it. But I was glad to see that some methods for which I had already defined my own extensions, like the compacted, first non-nil, or unique, are already implemented there. There are the one about taking chunks also, which can be super useful. The one about interceding values, which can be useful when writing tests to perturbate a bit the input data and make sure that your code handles the perturbation as it should, that it handles it gracefully. So in the end, I think for the top three, I think that's what I will do. I will do a recap email and video to just have the top three, because watching a 2 hour and 30 minutes video is not user friendly, we'll say. So I think top one will be the methods for which you might want to create your own extension, but here there is one already provided for you. So compacted, first non-nil, etc. The second one would be the chunks because for pagination, as it was said in the chat, it's super useful. And the third one would be the method that allow you to add some elements into to a clean piece of data so that for your test, I think it's a nice third one. And I think it's the three ones where like it doesn't feel like you're trying to force yourself to use the package just for the sake of using it. And I think this concludes our live stream. So thank you for joining. Thank you for following it. It's been quite a long live stream. Thanks a lot the people who posted messages in the chat. So Frank, of course, thank you for being super active and for being much more awake than I was at this time of the day. But thank you all. It's been once again a really good live stream. Really happy that I've covered this new package. I'm really happy with this new format where I get to learn new stuff, but I do it in a live stream, so I don't do it alone. I do it with people and I create a new piece of content while I do it. And then I will do the recap in my newsletter, email, and in a video either next week or the week after, so that there is a much more like bite-sized version of it with actionable takeaways. This way, people won't need to watch this very long replay to get actionable insight. And I say they won't need to, but I know that no one will watch the long replay to get actionable insight. Next package, Swift testing. Yes, Swift testing will happen during the summer. I started watching the WWDC sessions. I also have bookmarked the videos from the Swift and Tips channel on YouTube, which also covers Swift testing. And so I will do Swift testing over the summer, probably towards end of July, beginning of August. I'm not sure because I would like to find a sponsor, and actually I need to reply to an email on this topic just after the live stream because I hope that I will find a sponsor for this topic. I would love to, but if I don't, I will still cover it during the summer. So yeah, I think like at some point before mid-August, I will cover Swift testing because it's a very interesting framework and it leverages features of Swift like macros in a very smart way. So I definitely want to cover it. Thank you for asking. And I think it's the moment where I need to stop talking. My voice is begging me to, my throat is begging me to stop talking. So once again, thanks a lot for watching. Thank you for being active in the chat. And I say see you tomorrow for the video of the week. See you next week for another live stream. Or see you next time at some point on YouTube or on social media. Bye bye.